Hi, Assalamualaikum warahmatullahi wabarakatuh. This is the presentation.
Assalamu alaikum warahmatullahi wabarakatuh. We are Group 5, Section 1. Our group leader is Muhammad Sayafiq bin Ishaq, matric number DE190199. And the group members are Ainura Maisarah binti Ahmad Faris, DE190187, Woon Ching Kang, AE180110, and me, Suleiman Muhammad Kamaluddin, and my matric number is BE190010. I'm going through our abstract. It is described in this project how to create a high voltage suspension insulator, stacked insulator string, utilizing procedure that have been approved by the formal composition. On the other side, the proposal must be built the SketchUp software. The setup of proper testing high voltage testing has been devised, taking into account the necessary factors. On the other hand, we address risk assessment in relation to suspension insulator, stacked insulator string, in order to get additional information on the safety and reliability. The suspension insulator provide number of benefits of a chromium and glass insulators, including high performance in Bluetooth environments, lightweight, easy of handling, lack of maintenance, and a much low cost, among other characteristics. The purpose of this technical project is to discuss construction, types, design, and selection of glass high voltage disc insulator. Introduction. In the building of a DC tower system, insulator must be strong enough to handle the weight of conductor, bundles, and other supplementary loads. It is required to prevent current or any surface from passing through it electrically. We required sufficient data on the insulator's design, the employment of protective equipment, the size of length of the format installation, and performance estimates. It must be constructed to survive for a long time, provide sufficient insulation in various climate zones, and withstand proper damage. Before high voltage testing, there were two conditions: one with the contamination and one without contamination is being carried out. The high voltage directed current must be tested in both dry and wet conditions in this scenario conditions. To go on objectives, to observe the features of the ideal insulators for 132 kV high voltage suspension overhead line insulators, to develop high voltage insulators conceptually using SketchUp software, to analyze and simulate by using PEM software the stability of voltage and electrical field distribution of 132 kV insulators in dry and wet circumstances. Scopes of the study. The focus of this study on the insulator material that can withstand a high voltage 132 kV. To get this result, the material and concept must meet certain criteria, which is why the scope of study is as follows. SketchUp software is the design of conceptual insulator, evaluating the wet and dry environment 132 kV high voltage insulators, magnetic finite element FEMM methods, software simulation work are carried out. The insulation material must have the most advantage among the other materials, and its properties must be determined with the glass material and being emphasis of this project. And next, outcomes of final work. In order to prevent the current from flowing through or across their surface in the dry and wet condition, and to have the strength to support the weight and the bundles and load in order to accommodate for the user in the best possible performance. The simulation analysis for various scenarios and simulation methodologies have been classified and widely disseminated.
Have a good day to tutorial. My name is Wong Ching Kang. Can call me CK. My machine number is AE1800. And now I will do the presentation to the technical summary of Susan concept design. Geometrical configuration of the insulator. System voltage 132 kV. Type option string. Material option glass. Maximum length 1540 mm. Kpx clearance is the 7700 mm. Conductor is 175 mm. 2 triple AC. 15 option is K and pin. The conditions are dry with clean air and dry with contaminated air. Insulator is an essential component in the overhead line and the transmission line system. Insulator also play as an essential role to prevent the line damage from arcing and prevent the electric current from flowing to the unwanted region from the overhead conductor. In this project, we choose the glass as an insulator. This is because the glass insulator have high resistivity, low coefficient of thermal expansion, and higher dielectric strength as compared to other materials like porcelain. And at the same time, the glass insulator also have a very long lifespan because the mechanical and electrical property of glass are not affected by arcing. And now I will present the cross-sectional area of a cat and pin insulator. And this is the cat and pin insulator, and they are from few components, which is a ball socket, insulating glass, ball, petticoat, skirt, insulator head, and locking key. And the glass string, ball and pin socket insulator with arcing horn and guard ring for system voltage 132 kW. And from this picture, we can see the diameter of insulator, spacing between the insulator and the total insulator length, and the Kipes clearance, and the guard ring, and the arcing horn. And now I will present the description of component on glass this insulator. Okay, the insulating glass, the function is the insulating component made of glass, which is the core of the insulator. Gasket provide insulation between the iron cap and steel pin. Petticoat, an inner ring of glass inside the insulator skirt to overcome the wet insulator problem. Locking key, secure the coupling of the unit. Cement, attach the cap and pin. Collision sieve, prevent corrosion at the pin. Ball and ball socket. Suspension insulator N15 installed on the cross arm or tower to support insulator and conductor. Electrical and mechanical parameter design insulator. Designation, insulating material, and is the glass. Minimum mechanical falling load is 40 kN. Minimum mechanical resistance strength 32 kN, and diameter of the insulating part is the 180 mm. Spacing is the 150 mm. Kipes distance is the 2.112 m. Minimum Kipes clearance is the 16 mm kilowatt square, and the 15 ocean is the ball and socket. The ball and socket coupling is the socket 16B ball 60 mm. And puncture voltage in insulating medium, which the 100 kW, and dry power frequency withstand voltage is the 55 kW, and wet power frequency withstand voltage is the 33 kW. The dry lighting impulse withstand the voltage 1.2 divided by 50 is the 70 divided by 70. The ratio interference voltage dB divided by kilowatt, which is the 86 divided by 85. The weight is the 1.7. And now I will present the advantage and disadvantage of the glass insulator. The advantage: high dielectric strength, high resistivity, low coefficient of thermal expansion. Disadvantage: built by strong impact, moisture easily distill and easy to condense on the surface, easy absorb the contamination. Technical summary of finite element analysis FEA simulation software. For this project, the finite element analysis simulation software is to design, calculate, and analyze electrical stress performance in terms of high voltage and electric field. FEMN software used in this project is because it is a suite of programs for solving low-frequency electromagnetic problems on two-dimensional planar and axisymmetric domain. The program addresses both linear and non-linear magnetic and magnetostatic and time harmonic magnetic problems, as well as linear electrostatic one. For this project, the FEMN program is used to draw the suspension overhead insulator in 2D. The condition of the air is illustrated where is surrounded by the circle in this model. The FEMN most appealing characteristic is its ability to handle complex geometric and boundaries with relative case. In general, the bigger the number of elements in a mesh, the more precise the distributed solution. However, this comes a point at which the finding converge, and further merge refining has a little effect on accuracy. Process flow finite element analysis FEA simulation to the prototype. First we start and we define the problem. After we define the problem, we design the 2D geometry. And after we design 2D geometry, we'll come to define the motor material, properties, and boundary condition. And after that, we go to generate the mesh model, and we will post the processing result. So if we will come back to the design to 3D geometry, if yes, we will come to the record and analyze the data at the end. That's all my presentation, and my friend will continue to the presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Isa, and my matric number is DA10119. Okay, so for my part, I'll be presenting for the technical summary methodology and also the performance of the single disc insulator under the various influence of the wet, dry, and contaminated. Okay, so for the first, which is the step 1, define the problem. So for this problem, we have to take the electrostatic problem, which considers the electrical field. And then for the problem definition, the problem type should be taken as planar, and then the length unit is in millimeter. Okay, next we have the design the 2D geometry. So we can design our insulator using the 3 nodes created available on the task here, on the taskbar here. So this is the nodes, the segment and the out segment to create, we can use to create various kind of shapes. Okay, next we need to declare the materials for our insulator. So we must use the material library to take the available materials or add our own. So which is the cast iron which we had to add with the permittivity of 1000. Okay. Next is to define the property definition. So we have to make a new property which is include the 132 kilovolt and then 11 kilovolt and the 0 volt as a ground. So this is for the stack disc insulator and this is for the single disc. So this is how the 2D geometry design of the single disc looks like. Okay, next we have the generating the mesh model. So to generate the mesh model, we use these 3 tools out here, which is the mesh generator, the solver, and also the post processor. So after we do this 3 tools with sequence, we will get this result here, which is the generated mesh model of the insulator design we just made. Next, we have the post processing result. So to view the result, we can use this as to Y plot of field values to look at the plot type of voltage or the electrical field density. C, we can see the contour of the density plot of voltage. So we can see the density of the voltage here on the bottom conductor to the upper conductor. Okay, next is the performance of the single disc insulator in dry, wet, and contaminated. Okay, for the first one, we have the single disc insulator for the dry environment. So this is the electrical field density plot, which passes through the insulator here. So we have around 2.231 mega value of the electrical field, and then we have the wet environment. So for this one, we can see it shows on this bottom part here at the conductor. It has a very small this green light here, so very small. Okay, next we have for the contaminated environment. So for the contaminated, slightly bigger than the wet environment. Okay, so we go to the comparison of the voltage dry, wet, and contaminated for the potential volt. So for the potential volt, for all 3 of the treated, the result are similar, quite similar. Okay, so for the next one, which is the comparison for the electrical field density for the dry, wet, and contaminated. So we can see here for the dry, it is around 0.2 mega, okay, of the value for the electrical field, and then for the wet, it is quite the same as the dry. Okay, and then when we go to the contaminated, it has a higher value of the electrical field density based on the distance. Okay, so you can see it is significantly higher than the other 2 environment. Okay, so I think that's all for me. I will pass this on to Aino for her part on the stack disc insulator.
Thank you to my friend Muhammad Syafiq bin Ishaq. So hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ainur Maisara binti Ahmad Faris, and I will be presenting for the performance of stacked glass insulator in dry, wet, and contaminated condition. So now let's jump to the first slide. For the dry condition, so as we can see here, from the insulator, at the top of the insulator, it has the highest or the most intensity of the electric field here, and then it is around. We can see the density plot here for the color, such as if this is like some kind of yellowish to orangey, and I think it is around 2.865 mega volt per meter, and then it has the most electric field intensity at the bottom of the insulator here, and as we can see here at the at this part, it has a bit dark contour here, which is like I can tell that the density plot here are maybe 3.438 mega volt per meter. Next, for the wet condition. Okay, so for the wet condition, as we can see here that at the top of the insulator, it doesn't have any electric field intensity. It is not like the dry condition, but at the bottom of the insulator, it has a bit of the intensity here, but it's not that dark. It's just a light contour. Maybe the density plot here are around 4.768 mega volt per meter. Next is the contaminated condition. For the contaminated condition here, as you can see, it has more like almost perfect, that it doesn't have the electric field intensity. So at the top of the insulator, it doesn't have any field intensity. But if we can zoom here, maybe has a little bit, but it's not much as the dry condition. And then at the bottom of the insulator, this part has a bit intensity, but maybe it is not as dark contour as dry condition, and it is more light contour than the wet condition. So I think that it is maybe the density plot is 3.595 mega volt per meter. Now I will be explaining about the graph for the potential at the stacked in glass insulator for the dry, wet and contaminated condition. So I think there is no difference between them. It is still in the 132 kV. For the electric field, it might be have some kind of differences to those three conditions, which is the highest level of the electric field intensity for the condition is wet condition. I will be explaining this in the brief analysis later. Brief analysis of FEA simulation results and data observation. The insulator are tested in the three diverse conditions, which is dry, wet and contaminated. The contour of the potential distribution across a single insulator does not differ significantly in dry, wet or contamination condition as shown in the table 7.1. When the electric field strength is measured between the distance measured from the HV electrode, the contaminated insulator has a slightly higher voltage than the other conditions. For the maximum, table 7.2 shows the potential distribution that can also be described by the non-uniformity. So, based on the table 7.1, the show voltage in dry, wet and contamination condition, which is this is the for the single insulator. For the dry, we have the maximum electric potential. It is 12 kV, and then wet is 11 kV and contaminated 11 kV. For the electric field intensity, for the dry, wet and contamination condition for the single glass insulator, for the dry we have a 200 kV, 200 volt per meter, and then for the wet is 230 volt per meter, and the contamination is the 210 volt per meter. This means that this insulator, while the wet condition, it has the highest field intensity, which is not good, can be the disadvantage for this insulator. Next is the comparison for the 9-unit insulator in dry, wet and contamination. So from the table 7.3 below, we can tell that there is no changes on the electric potential value in those three conditions. But the value of the electric field intensity are slightly different from one another between the three conditions. From the table 7.4 below, we can tell that this insulator has the highest field intensity during the wet condition again, which can be the disadvantage to this insulator. So now, Let's focus on the table 7.3 first, which is for the stack insulator for the dry, wet and contaminated condition. The max electric potential for the dry condition is 132 kV, and also same with the wet and contaminated condition. And then for the table 5.4, for the electric field intensity for the dry, wet and contaminated condition for the stack glass insulator, for the dry condition, it has 430 30 k volt per meter, and then for the wet condition, it has a 490 k volt per meter, and then the contamination, it has the 450 volt per meter. This means that the intensity of the electric field at the stack and the single insulator are the same, which has the highest electric field intensity on the wet condition. So that's all from me. Thank you.
High voltage testing code of conduct. We look up test setup procedure. Disconnect the power supplement to the high voltage equipment by opening circuit breaker and opening insulator. Using profile line tester, confirm all phases are now conducted. The earthing switch now closed and all conductors are earthed. The insulation resistance tester conducting the conductor with safely earth connection on the prevent the operator from coming conductor and an earthing conductor while measuring insulation resistance. The safety earth disconnect after connecting the insulator resistance IR tester to the circuit. Insulation resistance test is applied and recorded. Safety earth reconnected after the testing completed. The simulation resistance tester was removed from the circuit at this point. Those are the testing setup procedures. And next safety aspect is appropriate clearance must be ensured to avoid accidental flashovers. Make sure high voltage laboratory always in dry condition to prevent sleep. Proper barriers must be constructed and sign board must be visible. Appropriate interlocks and shunt of electricity when the door or gate is opened must be installed on gates leading to live areas. All objects in the laboratory should be properly linked to the earth potential or be operated at a high voltage. Polluted things create complications. No individual should ever operate in high voltage laboratories. Conclusion from VEA work. PEMM software has been used to determine the concentrations of voltage and electric field on clean and contaminated insulators. It was found that contamination has influenced the amount of voltage and electric field. The distribution impacts can result on lead to surface or worse functionally or of the insulator. These results of the study may be important in the development and section insulators.
The title of our experiment is the high voltage insulator test using Mach generator under standard lighting impulse for wet and dry test. So we proceed to the method statement, and the title is the same lah. And the purpose is to observe the presence of flashover and analyze the withstand voltage rate. So for the equipment will be used is the DC supply, Mach generator, and glass cap and pin insulator, which is we designed in the proposal one. So in the specification of the Mach generator, so the criteria is the charging voltage is the 0 to 30 kilowatt DC, and the number of capacitor is used in Mach. N is the 20, and the capacitor of each capacitor is 21 microfarad, and the diameter of spark gap is the 50 mm, and the resistor of each tail resistor R is 50 ohm, and the total energy stored in Mach is 180 joules, and the output voltage of mesh load is the 300 kilowatt, and pulse duration is the 150 millisecond. So, and this is the circuit of the Mach generator. So we can know that the input voltage is 0 to 30 kilowatt DC lah, and this is the test in our insulator. The N is the 20, so we'll repeat the 20, and the capacitor is 21 microfarad, and the resistor is 50 ohm. So, and now I will present the experimental procedure. So from the DC input supply, we'll come to the mark generator. So in the mark generator, the starting is in parallel, and after that go to the series and go to the will produce the voltage output and go to the load. So from here we can know that the DC input voltage supply connect to the mark generator and connect to the glass cap and pin insulator. When the 30 kilowatt DC supply to the mark generator, initially voltage supply charge multiple capacitor simultaneously. So when the charging voltage become too high, discharge occur between the electrode and cause short circuit. Short circuits cause all the capacitor to be connected in series, and a high voltage is generated by adding up the charging voltage of each capacitor. Once the voltage output done generate, we'll start the wet and dry test under the standard lightning impulse. The withstand test was performed. Voltage supply as 1/50 square wave to the insulator. The performance of the insulator was observed and recorded. The dry test was performed. The voltage increased progressively and maintained for 1 minute power frequency. For 1 minute, the insulators must be able to the temporary over voltage without flash over. The performance of the insulator was observed and recorded. The wet test was performed. The insulator was sprayed with water at a 45-degree angle with a precipitation rate of 3 mm per minute. Water resistivity are 100 ohm per meter plus minus 10%. The voltage gradually increased until it reached the temporary over voltage and remained 1 minute. While the insulator was examined for puncture or breakdown, the performance of the insulator was recorded. So we continue to this table, which the risk assessment, which is the hazard. Okay, for the hazard will be occur possible consequence is the spark or fire. So the person within the building are at the risk. So how we can do is the fire extinguisher available in laboratory. Test equipment not be left unattended when initial operate to confirm behavior of sample. The second is a slip. For loss of water used to the wet sample, person entering the cache. Carefully handing of water to tap place with no more than is required to be placed within cache. Any liquid spirit to be mopped up immediately. Non-slip footwear and regular remove of waste and rubbish. Trip. Personnel entering cache need to be locked away from walkway where possible. Any lead that cannot be routed away from walkway to be covered with rubber matting. So we continue to the chemical usage within the experiment. For this experiment, we have using any chemical and we proceed to the hazard checklist. So when we do, we will know that is the hazard present or not. So the tripping hazard is present, the slipping hazard is present, the fire is present. So the high temperature, low temperature will not present, the high pressure and low pressure not present, the chemical spreaders not present, the chemical contract, injection, eye and skin contract not present, high noise level, working at high hazard, production of dust and fume, manual handling, production of use of radiation, use of aviation gas, and any other hazard, all is not present. So that's all my presentation, and my friend will continue to the presentation for the code of conduct. Thank you.